Hello class. Today we are going to talk about the steps needed for solving systems of inequalities. First we're going to go through the steps and a couple of things that we need to know, and then I'm going to work out a couple of examples for you. Step one, you need to make sure that you solve each equation for y and so that you can put the equation in slope-intercept form, which is y equals mx plus b. One thing you have to make sure you remember is that when you're solving a inequality equation, anytime you multiply or divide by a negative number, you have to switch the inequality sign. And we'll look at that on some of the examples to make sure you understand what we're talking about. Step two, you have to graph the inequality. We watched a video before on how to graph inequalities. We'll want to just make sure remind you, you have to make sure you understand whether it's a dash or a solid line, and the way that you tell that, if it's a dash line, if you have less than or greater than, and then it's a solid line if you have less than or equal to or greater than or equal to. And then you want to make sure that you're shading correctly. Now, in general, we're going to shade below anytime we have less than or equal to. And then we're going to shade above the line anytime that we have greater than or equal to. But also, I want to make sure you remember that you can always double check where you shade, and I'm always going to use 0, 0 whenever my line does not go through that point. I'm going to plug 0, 0 in for x and y in my equation and see if it makes it a true statement. If it makes it a true statement, that side is the side I shade. If it does not make it a true statement, then I shade the other side. So that is a way that you double check it. Next, after you've done that, your answer is where your shading overlaps. So once you have your shading done and you'll see the part where it overlaps, that's how you know what your answer is. Now, to solve some of these, we're going to look at a couple of examples here. Alright, now the equation we have is y is greater than or equal to 4, and then we have x minus 2y is less than or equal to 3. Now look at the first equation, y is greater than or equal to 4. The first thing I notice about that equation is that the variable is already by itself. But I also noticed that it doesn't have y equals mx plus b because it's a special type of line. Remember, anytime we have y is equal to or just y in a number, that means that we have a horizontal line. So at 4, we're going to have our line going straight across this way. Now the first thing we need to make sure remember is, do we have a solid or a dashed line? Because we have greater than or equal to, it is a solid line. So right here, I'm going to make a solid line going all the way through, and that is my line. Now, for the shading, again, I can see that by the shading, it's a greater than sign, so I would think that I should shade this region right here above. But I do want to make sure. So what I would do is I would plug in 0, 0. So I'm going to plug in 0 for y because that's the only variable I have. And I have 0 is greater than or equal to 4. Is that a true statement? No, it is not. 0 is not greater than 4. So we do not shade down here. We shade up here exactly where we thought. So all I do is just shade in that region. Okay? Now, I look at this second equation. I have x minus 2y is less than or equal to 3. When I start solving this problem, I need to try to get the y by itself. So remember, when we're solving an equation trying to isolate the variable, we need to use addition and subtraction to get the variable that we're solving for on one side and everything else on the other side. So the first thing I need to do is subtract x from both sides. And I'm going to be left with negative 2y on the left side, and then 3, or I need to write this as negative x plus 3 on this side. And I wrote it in that way because I need y equals mx plus b format. Okay, now have I multiplied or divided by a negative yet? No, I only subtracted x, so my inequality sign does not change. Next thing I'm going to do is divide both sides by -2. Now when I divide by -2, I am going to cancel it out on this side, and I have y, and then over here I have a 1 right here, so I have -1 over -2. I'm going to change that to a positive because the negative divided by a negative is positive, and then I have 1/2 x, and then I have 3 over -2, and I can keep it that way, but because that is my y-intercept, I am going to go ahead and change it to a fraction, to a decimal, so I'm going to have -1.5. Now, I divided by a negative right here. Because I divided by a negative, I have to switch my inequality sign. So instead of being less than or equal to, it's going to turn to greater than or equal to. So now I have y is greater than or equal to 1/2 x minus 1.5. So this is where we have to remember our graphing rules. I'm going to start at -1/2, which is right here. I'm going to make a point. Now I'm going to go up 1, and then I'm going to go to the right 2. And I have a point there. Then I'm going to go up 1, to the right 2, 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 and then up 1, to the right 2. Now, I carried it out that far because I want to make sure I get my intersection. So I am going to make a straight line the best I can. And why I made it a solid line, because we have because right here we have greater than or equal to. Now because it's greater than or equal to, I think I'm going to shade up here, and I'm going to plug in 0, 0 again to make sure I have 0 is greater than or equal to 1/2 times 0 minus 1.5. And if I look, I have 0 is greater than or equal to negative 1.5. And so this is a true statement. So that means where the side that 0, 0 is on is where I'm going to shade. So that means, and you know what, let me grab a different color so that we can see the overlapping clearly. And I'm going to have all of this is what I'm shading. And so that would mean that everywhere where you see the pencil shading and the colored pencil shading, that is part of my solution. Okay? Now, we're going to look at another example, and I want you to go ahead and try to solve this one yourself. So pause the video, try to solve it, and graph it, and then play the video again to see if you was correct. But first, when I have x plus y is less than 2. So what I am going to do first is solve this equation for y. I'm going to subtract x on both sides, and I'm going to get y is less than negative x plus 2. Then I'm going to solve this second one. I'm going to subtract x from both sides again, and I'm going to get negative y is greater than or equal to negative x minus 3. Then I'm going to divide both sides by -1, and I'm going to get y. Because I divided by a negative, I'm going to switch my sign, and then I'm going to have -1 divided by -1 is just the negatives are going to cancel out right here. So I have x plus 3. Okay, so the first thing I'm going to do is I'm going to graph the first equation first. We have y is less than -x plus 2. So I know I'm going to start at 2 as my y-intercept, and I have my slope is -1 over 1. Okay, so that means I'm going to go down 1 and to the right 1. And I'm going to keep doing that. And I like to do a lot of points because I can't draw the straightest of lines, and I want to be as accurate as possible. Then I'm going to go the opposite direction. I'm going to go up 1 and to the left 1. I'm going to keep doing that. So that is going to be the path of my line. Now I need to determine, am I going to have a solid line or a dashed line? So I'm looking at this right here. It is less than. And earlier we looked at when it's less than, we're going to have a dashed line. So I'm going to make a dashed line the best I can. And if you see, I try to make sure my line is extended so that everything is as accurate as possible. I can't make a line and it only be this part of the graph, especially when we're graphing inequalities. Now, it said less than. So if I see less than, I'm thinking that down here is below the line. Okay? But if I check it, I'm going to have 0 is less than -1 times 0 is going to be 0, so I'm just going to write 2. Is 0 less than 2? Yes, it is. So that is a true statement. So this is where I would shade. So all of that would be the shading for that. And so we understand, I want to make sure we understand something. The shaded region, what this means is that any point that's in this shaded region is a solution to this inequality, meaning it will make it a true statement. Now, on the second one, I know that my, first of all, my point of where I'm going to start on the y-axis is right here at 3. And then my slope is +1 over 1, meaning I'm going to go up 1 to the right 1, up 1, right 1, and that's going to continue going. Then, to go the opposite direction, I'm going to go down 1 to the left 1. Okay, so down 1, left 1. I'm going to keep doing that. And again, I'm carrying it out as far as possible so that my line is accurate as possible. Now, I have a less than or equal to sign. So that means I'm going to have a solid line. So, connect those points. And I have my solid line. So that's what my line will look like. Now that I have my two lines, I need to figure out where do I shade this second line. Well, it said less than or equal to, so I would think that's all of this region here. But again, I'm going to plug in 0. I'm going to have 0. 1 times 0 is 0. So I'm going to have 0 is less than 3. That is a true statement. So the side that 0, 0 is on is the side that we're going to shade. So all of this will be shaded. Now, the important thing to remember is that the shaded region right here that has the pencil shading and the colored pencil shading, that is our solution to this system of equations. So that would be the area that is part of our solution set. The thing we need to remember is that this dash line means it's a dash line because if we're talking about a point that's directly on that line, it is not part of the solution. But if it's on this solid line right here, it is part of the solution because it's a solid line. Okay, that's an important fact we need to remember, because you could be asked a question that is asking you if a point on the dash line or solid line as part of your solution set. Okay, let me give you one more problem, and this one I want you to complete yourself and show it to me so I can see if you understand what you are doing about it.